Hi, I'm Yesu and I'll be talking about Euler's method today. We are given the differential equation and our initial values. We're expected to find the y value at x equal to 1. The thing is, we divide x into equal parts. This point here will be our final x value, which is 1. And this will be the y value at x equal to 1. These are the points where x meet on the curve. First, we connect these 2 points and find the gradient, which is rise over run, where run is the difference between x1 and x0, which is equal to h. Rise is the difference between y at x1 and y0. This value can be easily calculated by using the differential equation of x0 and y0. Using the gradient, we can draw a tangent line at that point. This point here will be y1. Again, we will find the gradient at the point y1, which turns out to be equal to the gradient that we find earlier. Rearranging the formula, we will get something like this, and for m we use the differential equation. We repeat this for y2 as well, and we will get the y2 value. Same thing goes for y3 and y4. As we repeat this formula, we get what we call the Euler's formula. Our calculated y value is 1.915 and our estimated value is 1.91138. The difference between them is called the approximation error, where we get 0.00362. However, the error will be smaller if we use smaller step size. This is our step size, which is 0.1, which means it will take 10 steps to reach the value x1. To calculate our x1, we will add on our step size to x0, which is step size plus x0. And we will get 0.1. We repeat this until we reach the value x equal to 1. For this function here, we will use the differential equation given here. So, to find f of x0, y0, x0 squared plus 1 over y0. So we get a value. Now we can calculate our y1. y1 equals to y0 plus step size into f of x0, y0. The same thing for y2 as well. That's how we get our y2, and we repeat this until we reach the x value 1. Now we get our y value 1.91138 at x equal to 1. As you can see, the estimated y value and our actual y value is a bit different. The difference between them is called the approximation error. Now we will calculate our error. I will subtract these two. This is the value I got, 0.00362. I also tried finding the y value using a smaller step size, which is 0.05, and I got the value 1.91293. Now I will try finding the difference. Subtract these two. The error is smaller than the first error. This is because I used a smaller step size. That's why we can conclude that as we use a smaller step size, we get a smaller and closer error. Thank you for watching.